Bandwidth for Changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at Changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. This episode is brought to you by Linode, our cloud server of choice. It's so easy to get started with Linode. Servers start at just $5 a month for your big ideas. Head to linode.com/changelog. Choose your flavor of Linux that works for you, then pick a location that's right for you. London, Tokyo, Dallas, and many other places in the world. They've got you covered. Go from having that amazing shower idea to a hosted website in just minutes. Start small, expand as your idea blossoms into a huge hit. And we trust Linode because they keep it fast, they keep it simple. Check them out at linode.com/changelog. All right, welcome back, everyone. This is the Changelog, a podcast featuring the hackers, the leaders, and the innovators of software development. I'm Adam Stacoviak, editor-in-chief here at Changelog. On today's show, we're talking to ML Hussain about ASTs, aka abstract syntax trees. ML is giving a talk at All Things Open on the subject, so we asked her to give us an early preview of it. She's on a mission to democratize the knowledge and usage of ASTs to push legacy code and the web forward. And by the way, we'll be at All Things Open. We're hosting a live JS party on stage. Plus, Jared is giving a talk on Svelte for a radical new approach to building user interfaces. And as a special thanks from the team behind All Things Open, we're giving away 5 free passes to the conference. And all you have to do is tweet, "I want a free pass to All Things Open because," and state your reason why. And copy at Changelog and at All Things Open in the tweet. We'll send DMs to each winner next Friday, September 27th. Good luck and enjoy the show. Oh, one more thing. For those who don't want to wait and just want 20% off your pass right now, use the code CHANGELOG20 when you buy your tickets. The code is unlimited, so tell your friends. Head to allthingsopen.com to learn more and register.
So, Mel, thanks for joining us. First of all, congratulations to your first week as engineering manager at NPM. It's bittersweet. Tell us what's new here.
Thanks so much, Jared and Adam. So hi, everyone. My name is ML Hussain. I am a new engineering manager at NPM. It's my first week. And I came to NPM via Boku, where I was an open web engineer working on some pretty awesome stuff in terms of web conformance suite testing with browser interoperability, as well as working most recently on Game Bender, which is a Scratch-based game console, which uses computer vision and all this other cool stuff, all open web APIs, and to teach kids how to code creatively.
So that's what you were doing at Boku, or that's what you're doing now at NPM?
That's what I was doing at Boku. I was doing a lot of work around product, I would say product engineering, and really it became very clear to me that I needed to kind of boss up a little bit because I was, consistent, like just really, I think, strong at managing up, sideways, down, and for a pretty large project. I was a tech lead for that project, and I'm stepping into my love of product by, being an engineering manager, which combines the best of, I think for me, the best of both worlds, which, you're able to be hands-on with the team and drive technical strategy. And you're also able to work with all of the stakeholders that are involved in the software delivery process. And it's just something that I really enjoy doing. I've kind of consistently been the go-to person at every team, at every company for a variety of things. Yeah. And so it was a really difficult decision to make, if I'm honest. It was very, very difficult. I identify as a woman and as a person of color. And for me to kind of walk away from the full-time responsibilities of delivering software, just that aspect, it was a very difficult decision. But I realized that there's even less of me, in engineering leadership. And so, that's where I think I get some kind of solace, which, I'm giving folks an opportunity to have like a woman of color as a manager, which is a very rare thing for most people in our industry. So.
Well, that's awesome. I'll say congratulations and good luck because you're just getting started. I hope you have a lot of success
Thank
there.
you.
Boss up. It's time. It was time to boss up. I like that.
I like
It was time to boss up. It was time to boss up and own my bossiness too, which, it's so you just have to take a step back and realize, like, you know what? Hey, I can do this. It's quite simply that, and I think a lot more folks from our industry need to make the hard decision that I made, because there's a ton of really bad managers. There's folks who really don't focus enough on mentoring, or don't focus enough on just kind of the overall technical strategy. So
I'll tell you what, though, being a leader is one of the toughest positions, because you get criticized, scrutinized, not only by yourself, which is where it usually begins, but then also from the externals. People who don't even know you will criticize you. And then people who really know you will also criticize you. So
everybody's
being a leader is tough.
Yeah.
It's a really tough position. And that one in particular that you mentioned, with interfacing with so many stakeholders, it really requires somebody who's very empathetic, right? Can see all sides, kind of put them in positions of everyone else's position to sort of like drive the ball forward and take nothing personal, or at least try to.
Yeah, I agree wholeheartedly with your analysis there. It's there's a great quote, "Heavy lays the head who wears the crown," or something like that. And there's a lot of I think freedom you get in a leadership role, where there's a lot of autonomy. You're able to kind of drive decisions and really make an impact for good or for bad. But with that comes a lot of responsibility, and one of those is like taking responsibility for failures or like missed opportunities. And I think what's interesting at NPM and about this is, I've always had a dream of being a tool maker. Tooling, and that's kind of like my stuff. Like that's like my jam, right? It's kind of always into kind of architecture, infrastructure, like how things connect. I'm very much like an in-between person. When I worked on server-side code, middleware was like something that was interesting to me, because it touched because of the intersectional nature of it. And so at NPM, in many ways, like I'm fulfilling my lifelong dream of being a tool maker, and I think as an engineer that's a tool maker, we have the toughest customers, because, people are relying on us to then do their jobs and like make their magic happen. And so there's this extra layer of like not only scrutiny, but also really we're the toughest customers, software engineers, because we can make we're the toughest customers, because we make we can make the thing that we're using if we really sat down.
And sometimes you do. Sometimes you make your own thing because somebody else's thing isn't good enough.
Right.
You got two things.
Right. Is anybody else's thing ever good enough? Let's be honest, if you could wave a magic wand and have the skills to write your own IDE, in a day or a week, I bet you would, because you want it your way. And so, there's an arrogance and there's a pickiness in our industry, and much of that I think is to be expected. We have really hard jobs, because ultimately the engineers that kind of criticize you as a tool maker, that serves them, those same engineers are also criticized by their users and customers, right? So ultimately they're also being judged. So they're going to be, it's like an exponential judging chain, right?
What's interesting there is that contentment is often the enemy of progress, right? So like if you're content, you tend to not want to progress and get better. So then you have this idea of discontentment sort of like becoming a norm in our industry, where in some cases discontentment is sort of frowned upon, right? Like to be discontent means it's just like not a good position to be in, I suppose.
Because it breeds envy and jealousy.
Right. And so, as an industry, just based on the desire to progress, which we all want to, because that means that our tooling gets better, our software gets better, et cetera. If we have to live lives of discontentment, I wonder how that really impacts us psychologically in our industry.
Yeah, I think that's like, I think that is a topic that I would like to dive into. Like not right now, right here, but definitely in the future, because I think there's like the intersection of like psychology and like all of the pressures that are on us as engineers, and like the continuous improvement, continuous change. Like I wish we had like more cultural anthropologists that were studying technologists, because I think there's a lot of really insightful behavior and just insightful things in general that, that are probably very unique to our industry, and how those things kind of play out on our lives outside of the terminal, is, I think that's another really interesting story.
Beyond the terminal, I like that.
Yeah, beyond the terminal. Yeah, buy that domain now.
Sounds like a podcast.
Since you mentioned your desire for this, it sounds like a podcast we're actually creating called Brain Science.
That's true.
Oh, we have, that's dope.
In the prequel, I think we mentioned...
Maybe I should be on your podcast.
We're actually taking guests sometime soon. We want to dive into this. We're exploring the inner workings of the human brain to understand things like behavior change, habit formation, mental health, and basically what it means to be human. So brain science applied, not just what do we know about the brain, but how can we apply what we know about the brain to sort of transform our lives and better our lives? And some of that is this anthropologist type approach towards our industry.
Yeah, I'm really happy to hear that. There was a major at my college that was called was it Society, Technology, and Policy, and there I thought that if I was like 20 years older when I went to school, like I feel like that's what I would have done, because I find I would have probably done that as like a double major, because it's for me, I consider myself like a very intersectional human, because of a variety of things, like not just my family background and like life experiences, but even just my interests within the industry. I'm an engineering manager. Like that job is hugely intersectional, and so the like I think that's like a super relevant thing to like explore, and what the effects of that are like moving forward, like as we progress in this like new and uncharted like territory of the digital age. So
well, I'll add one more layer to that. We often look at the internet as in like so many years, like being a teenager. I think it's about 20 years old now.
I remember a couple of years ago it got its driver's license. So I think that's probably around drinking age, like 21 in the US.
So I know that software's been around longer than that, but that would mean that in a similar way, engineers in that era are similar in their maturity level. Not so much individually, but corporately.
Meaning that we've been doing this internet thing for the same amount of time the internet's been around?
Basically, yeah. So we can assume, I would say to some degree, that our awareness of how to best drive the thing is predicated on how old the thing is.
Definitely a young industry.
Right.
Yeah.
So we're still learning. We make mistakes, and that's human.
And a changing industry, right?
It's human.
I mean, physicists, there's a lot to learn beyond like astrophysicists, right? But like the basics of physics are the same as they've been. And so that's a thing where...
Theoretically.
Yeah, I go back to the idea of civil engineering, right? Like how to build a bridge in a structurally sound manner is a tried and true science.
Right. It doesn't change every year.
You could have written that book 100 years ago and it'd be slightly different now, but it'd be pretty much the same foundations. Whereas we're kind of like figuring out this software engineering, network-based industry where we live our lives and we have our jobs, and they're kind of like in the same milieu, and like all that kind of stuff we're very much living it out as we're trying to develop it, and we're making mistakes that impact people that we don't even know, et cetera, et cetera. So it's very young, and therefore I feel like we really don't understand what all the implications are at this point.
Yeah, I want to go a little deep, a little, like, I would say a dollar store philosophy, maybe on y'all, which is, here's my dollar store philosophy. So what's really interesting about about the web is not only like how young it is, but also like the impact that it's had in the amount of time, right? And just how like exponential it is in so many ways. And then you look at the kind of under the hood experience with developers and just how much change we've had, and how actually developing for the web is like an extremely hostile thing, and what other industry do you know that, where we create like, we're like, well, hope this works, right? ship this, and I hope this works, right? And and it's really interesting to kind of like watch the transitions that we've had, where 15 years ago, or more, it was like, hey, actually probably about 15 years ago, it was like, hey, a user comes to a website and server's like, hey, tell me who you are. And it's like Netscape, and then it's like, okay, here's your code for Netscape, right? It's like we've come a long way. For sure. Even just in that, where we're now driven by features, more of like progressive enhancement, but it's still very hostile, right? Because there's a ton of variability now. It's a different type of variability. It's not so much that browsers have a really, a low interoperability score. It's that browsers are, they're just so much more powerful, and there's a bunch of other like capabilities. There's assumptions that you can make on the device size. There's assumptions that you can or can't make on the capabilities that are enabled, and so there's just it's like the matrix is growing, and the problems are changing, and so it's really interesting. I kind of think of it like quantum computing style. Like there's just so many things.
Some of this might even lead into the bigger topic we're here to talk about too, which is ASTs and legacy code and stuff like that.
Yes. Maybe a smaller topic, actually.
Yes.
Well, something I want to say is that yesterday's choices are today's consequences, right? Like, so yesterday's choices, and we're talking about our maturity level in terms of an industry and people, and even as an internet, that we're still learning. But yesterday's choices are today's consequences, and that's kind of where we get legacy code from, and this need to transpile it into to new ways and take care of tech debt and all these things that sort of come along with building software.
Good segue, Adam. Good segue.
Yeah, great segue. I saw that segue coming because I'm a podcaster myself. I was like, we're getting there. This is a long-winded
I saw it coming as well, and it was so smooth that I decided to call it out and make it completely not smooth and destroy
That's right.
I actually killed the segue.
You just janked it up.
Fine,
it's
Jared.
okay.
We
forgive you.
Thank you for the forgiveness.
But yes, change. The internet is change, right? So it's all about change. And that's what we're here to talk about, because I'm really excited. I'm going to be talking about ASTs at All Things Open this fall. I'm here to answer all of your questions, Jared and Adam.
Give us the rundown from the uninitiated standpoint. So what are ASTs? Who uses them? Why do they use them? What's their purpose, etc.?
Sure. So when we write software nowadays, it's really high level, right? var equals foo. It's human readable words that are high level, and in order for those things to kind of be fed into a machine, and for your code to get turned into ones and zeros, there's a series of steps that it goes through a compiler engine. And so one of the first steps is taking your code and tokenizing it. Tokenizing is a process where, the valid like syntax items, right? So in JavaScript, that might be like triple equals is syntax, const is like is a token. Like all of these things are kind of parsed, and then a tree. So it's tokenized, and then we a tree is generated from the structure of your code. And so that tree is called an abstract syntax tree. It's not limited to JavaScript. It's, every programming language uses abstract syntax trees to kind of feed into the compiler engine, which, translates all of that stuff down to bytecode. And the abstract syntax trees are extremely useful in programming, because they give us a predictable data structure, which helps us understand our code. And so if you're looking at a variable declaration, for example, const Jared equals, string awesome.
That's what I was going to say.
So that yeah, right. That one line of code, including the semicolon, gets translated into a tree that has a predictable structure where, the first thing is, it's a JSON tree that has a type program. It has a body that's an array. That body has declarations of which is an array, and the of objects, the object type tree, right? And so it gives you this lovely output, which is like a programmatic walkthrough of your code, and the kind of secret sauce to ASTs here is that there's a structure for you to understand what something is, right? So you can understand like const Jared equals string awesome. I know that the identifier, it's a variable declarator, and the value is Jared, and I know that that the awesome is a string, and so there's no guesswork, right? And so, and if you think about things like regular expressions that we've used to kind of really parse and understand our code to like find like matches, there's a lot of there's inherently like a conflict between like trying to find something with regex versus like using something like a tree like that has a lot more detail and metadata, because the regular expressions are really good for analyzing static code, and also but they're really not good at understanding kind of the nuances about like the differences in your code. So I'll give you an example. So if you have like a comment that's if you have something that's commented out, that's a variable declaration versus something that isn't. If you have a function that uses the same name as the variable, right? So if you're trying to find matches for that thing, like it's very difficult for you. You can do it. Technically you can. It's like just an extremely complicated set of regex that you would have to write, in order to find, to make sure that the thing that you are looking for is a function. So so what this tree allows us to do is it basically, it opens up a whole, like body of being able to really query your code, and query it in a way that is extremely precise and scapular. So you can say, I want to find all of the functions that have this, that contain these conditions, that the conditions maybe being things that are longer, that have, more than 10 variable declarations, things that have like more than, 4 if statements, functions with more than one, more than like 20 lines of, I want to find promises that, don't have catch, like they don't have error handling, right? And so it enables us to do a multitude of things in order to like understand our code programmatically and deterministically. And then the flip side of that is using tools that allow us to take ASTs and transform the code so that we can actually do like an in-place replacement. Like you can now not only programmatically understand like your code and find things, but also you can use that to do safe in-place refactoring of your code.
This episode is brought to you by Git Prime. Git Prime helps software teams accelerate their velocity and release products faster by turning historical Git data into easy to understand insights and reports. Because past performance predicts future performance, Git Prime can examine your Git data to identify bottlenecks, compare sprints and releases over time, and enable data-driven discussions about engineering and product development. Ship faster because you know more, not because you're rushing. Get started at gitprime.com/changelog. That's gitprime.com/changelog. Again, gitprime.com/changelog.
title of your talk is Machine Powered Refactoring, Leverage ASTs to Push Your Legacy Code and the Web Forward. You just described what ASTs are and what's interesting about them. I think historically, ASTs have been really much the playground or the domain of people who are writing languages or thinking about programming languages and have to have parsers that produce ASTs in order to, take a syntax and turn it into a thing a machine can understand. It sounds like what you're arguing for is that there's a much more mainstream use case for ASTs where lots of developers should know what they are and be able to use them because they provide this metadata and this structure, and we can use them not just to write programming language, but to actually refactor, which is, I've never thought of this before. Can you expand on how you've done this, how it works? And is this something that lots of people should be using?
It's really important for me to kind of democratize this knowledge because most developers don't realize that they are actually already using ASTs every day in their workflows if they use things like Babel, or Prettier, or ESLint. All of these tools, we allow these tools to programmatically create code for us and change code for us, and we trust them because of the precision nature that comes from leveraging ASTs. And so there's a whole domain of, I think, there's a domain of tools as well as a domain, like some domain areas in our industry. ASTs being one of them that are kind of locked away
esoteric
in the library author land,
for sure.
Right? And what happens with library author land is, folks are really busy. They're maintainers for really large projects, and they're already overburdened. And getting good documentation is a challenge that like most folks have out of their projects. So kind of taking the step to democratize the power of this is kind of been left on, like I would say us as a wider community. And so I've been able to leverage ASTs actually. I worked on a project at Boku where we were working with the Edge team. This is a while ago, to modernize like thousands of tests that were actually written for IE, but that were valid. So these tests were valid because, the web platform is, we don't break the web. And so, when we implement the CSS feature or when we implement this API, it's typically stable. We usually enhance it. And so there's thousands of tests that were written for IE that were still valid for the web platform because they were testing, open web standard APIs. But it was using an outdated harness. It was using a bunch of proprietary stuff, et cetera. So we needed to modernize it and get those tests ready to be shared with the entire world, via web platform tests, which is a project where all of the browsers, browser engineers contribute and now have a shared test suite. And so there were a lot of similar patterns, but there were also a ton of conditions. And so I was able to leverage ASTs to help me power through a bunch of refactoring for thousands of tests. And I was able to kind of make those changes safely. And had I done that work manually, it would have been just X number of days more. And not only that, but it's just error prone and not a good use of a human brain. And so I'm very pro automating repetitive work, also using automation to kind of gate your to limit your risk, but also to make it easier for you to repeat and rinse and iterate fast. And when you use automated refactoring, what you're able to do is build up a set of transforms. You're able to change thousands of files at once, and if you did something wrong, you just redo it. You just git check out, change your transform, and then run your refactoring again. And so that type of quick feedback loop is necessary to be productive in 2019 and beyond. And so, we really need to examine what type of architecture and what type of, I would say not architecture, what types of best practices that like we as a community have, because we are entering, an age where we have a ton of aging code and infrastructure because our standards are changing so fast. And NPM dependencies are great. That's like that's a good case study for looking at change, right? So if a library author changes an API, or if you have like an internal private module and you want to deprecate something, you can use ASTs to to upgrade to a newer version of the API safely. You can also use ASTs to write your own custom linting rules around, hey, I don't want anyone adding new versions of this. Like I have a hard-coded count of all of the instances of this thing, and I don't want any new things added into my test. I don't want any new instances of this deprecated module being used. And, so you can make that decision binary, and you can enforce those things for your team, in a way that's binary and where, you're not having folks having unproductive discussions, right? So I'm a huge fan of like, no nits, no, our code reviews shouldn't be, we shouldn't be like arguing over things that are team conventions or like what previously agreed upon things, So brain power is expensive, and if you make it binary, it's harder to have you'll have more productive discussions in code review, right? Like let's not talk about linting, let's not talk about this. And lastly, what I'll say is that using ASTs is one way to really, I think, add a resilience layer to your code base, right? Because, if you're fixing a bug, the first thing you should ask yourself is, all right, I fixed this bug. Could I have avoided this with like a linting rule? And if the answer is no, the next question is, okay, could I have avoided this with like an integration test, right? A unit test. And if the answer is no, then integration test, right? So you can, it's kind of the first, for me, it's like writing your own custom linting rules or custom transforms, and all of these things are like a first layer defense for a lot of things in code bases that are easy.
Do ASTs typically be written in the language that you're testing against? Where do you begin? Like, what language are they written in? Are they a separate project? Do they live inside the mono repo? What's the landscape?
Yeah, great question. I've only worked with JavaScript in terms of using tools around ASTs and JavaScript, and so what you need is a parser, and there are projects like Babel that have their own, their own parser, Esprima, Recast. There's tons of different JavaScript parsers, and the differences are like really nuanced because they all have the same general structure, but then they have some additional information, the trees that the ASTs trees that they output have a different information based on what the preferences are of that tool in terms of how they want to traverse their trees, etc. But typically, it's a three-step process. So the first thing you need is actually a diagram here. I was going to say, should I share my screen? But this is a podcast, so we're going to have to talk through a diagram. So, you need a parser, a transformer, and a generator. And so the parsing tool basically just creates a tree for the input code. And then you have a transform that basically lets you query the generated tree. And then you can say, oh, here, I found the thing in the tree that I want. Now let me, create a new AST, let me create a new structure for what I want to replace, if I want to change the value of something, or if I want to, remove something or whatever, let me make that change in the tree. And basically a new tree gets generated from from all of the transforms. And then that tree that gets generated now needs to go back into code. So that's the third step, right? So we need a generator. So that's like the reverse. It's the reverse of the parser. So it takes a tree and then it makes code. And so those are kind of the three things. But we typically so depending on what tool you're using, you're kind of chaining together a parser, a traverser, a transformer, a generator, or you're using something that like does everything for you altogether. JS CodeShift is what I really like to use because it's a wrapper for Recast, which uses Esprima from Mozilla. It's a parser from Mozilla. JS CodeShift wraps Recast and gives it a very nice jQuery style declarative API. So it's just really nice to write. And the folks at Facebook are behind JS CodeShift, but Recast is you can also use Recast, which is great. I just enjoy the declarative nature of using a tool like JS CodeShift. But you're using JavaScript to write all those things, and there's an API that usually comes with whatever tool you're using, so that you can query, but then you can also create. And then there's the last step, which is okay. Now that I've queried and I've created and I've now kind of generate the tree and do an in-file replacement. And so in theory, like the entire, like when you Babelify or whatever, or when you run ESLint, if you use -- fix to make the change, in theory, like the whole thing actually changes, but Git only shows the diff, right? So you only see the diff. So the whole tree, the whole file got replaced in place.
So if we just take a simple example, maybe walk it through these three steps. If we had a simple example of refactoring is let's change all of our vars to const, for example. So I have all these var statements. I want to use const instead, and I'm going to use an AST in order to do that. So the first step would be take my file or my chunk of code that has the vars in it, pass it through the parser, right? So I have raw text. I'm passing it to a parser. The parser then generates the AST for me, returns an AST.
Yep.
Can I read that AST with my eyes, or is it a blob, or like if you like
can
Matrix
read that
style,
AST.
just
so you
kind
can
of
use an AS. You can print it, you can log it, or you can use an awesome tool that I like to use, which is really, I think, kind of the standard around this. It's astexplorer.net. It's a site which allows you to just place, just drop code, pick your parser, pick your language, and you can view the tree.
Cool.
And so the really great thing is you can use this tool to visualize a tree. So there's no memorization here. Like I don't need to know what the tree structure is for a function with that has a return value of this. Like I can just drop it in and see the tree, and then I can write the code for what I want to change it to, and then see what that tree is. And so that, you can do reverse engineering to basically say, this is what I want to find, and this is what I want to change it to, or you have both versions, and you can use that to drive your, how you build your transforms. Okay. And the best part about it is like, this is all written in JavaScript. So you can, these are node scripts that are running, and you can basically do anything you want in the middle of a transform. If you want, you can say, oh, find me this like static list of static array list of, I don't know, images from some cloud server, and you can run a transform to say, and then in your transform you can do an API request, get an updated list, do an in-place replacement, right? So you can do kind of dynamic evaluations of your code, so that you can actually have, like, even though your code is static, it can actually be dynamic. You can use transforms to even like change your code or do pre-evaluations and things like that. So it's very interesting.
That is interesting. So yeah, AST Explorer, I'll definitely recommend. I'm pulling it up here. We'll link it in the show notes if you want to quick click on it. I think part of the ASTs is there's like this, like you said, you're trying to democratize this knowledge. There is like a mystical aspect of once you get below source code, you're like, okay, we're now at a machine generated thing. That's scary. can I view it? Can I, it just seems like a little bit more nebulous, a little bit more vague. Abstract maybe might be a good term. But this does a good job, I think, just looking at the example. And I'm sure as you put in your own code into something like this, it probably does a good job of demystifying some of that and saying, you know what, this is not all that unapproachable, and something that is very valuable if you can get past maybe a little bit of that abstractness. So making it more concrete now. Once I have my AST, like you said, you can transform it. So the transformer operation, is that depending on the transforming tool that you are using? You mentioned a couple of different tools, and one has like a jQuery style syntax. What would it be like if I was like, take all my vars and make them const? Obviously, you don't have to like type out the code to us, but like what kind of a transform would that be?
Well, you would say, so if you're on AST.NET, for example, you can pick JS CodeShift as your transform tool. And
Nice.
You would basically say, so it uses a declarative jQuery style API. So, your first thing is you're looking at the file source, and then you're saying .find. I'm looking for an identifier. So I'm looking for like a variable name or a function name. And I'm now, and then, so find, identifier, and then for each, right? So it's just JavaScript. You just
looping.
Iterate on all of the identifiers that you find, and then you can match. You can have a matching. So you can say if that node name is Jared, like replace the value to be awesome, and that's it, and then .to source, which like prints the change, prints the transform tree back to the same file. And so it's as simple as that. It's actually mind-blowingly easy. Like on the JavaScript complexity metric of like, this ranks really low. I mean, this is way below like TypeScript in my opinion, for example. Like the like, people look at TypeScript and they're like, I don't understand this, this is like, and then like a week later, they're like, oh my God, I'm converted forever. Like for me, the barrier to entry when I teach folks about ASTs is even lower than that. Like as soon as I show them an example, they're like 3 minutes later, they're like, I'm sold.
I'm basically looking at this example right here, and I'm pretty much sold as well, because this is way more simple than I would expect it to be. I figured it'd be a bigger buy-in. At least to get started, it seems like it's pretty straightforward.
The tooling has made it really easy.
When do you reach for something like this in terms of complexity? Because the simple example of like change my vars to const in my text editor, I can basically hit Command Shift A and just type in find all const and replace with var. So there's certain things that our IDEs or our editors make those kind of refactorings pretty straightforward, like a find all and replace. But then when do you know, and it's a little bit too complex, but maybe it's just kind of like case by case, you'll just know it when you need it? Or I guess maybe the better question is like, is there enough of a barrier where you don't reach for this right away, but you kind of like upgrade to it when it gets to a certain level of complexity?
Yeah, I think that's a great question. I think it's about understanding what your needs are, and what type of change you're trying to make. If you're trying to make something that's really simple and self-contained and something that you can just do with a find replace, great. But anytime your change is conditional, or anytime your change is like more than one line, right? So if it's like a multi-line change, that's where you really, if you're moving around function parameters or like I would say deleting code, things like that. There's I would say that for the true needs of like what we would do as developers to kind of refactor a set of hairy code that's widespread, that's when I would use like a transform. So I would say that like scale, right? So like if something is repeated in multiple areas, if there's something that's a clear pattern, if you're updating something that where it can be really hard for kind of a regex to kind of pick up on the differences between things, like for example modules, when they're being imported, like I can also use the star syntax to change the name of something, right? So import foo, as star, like right, there's lots of little nuances there, and you can use ASTs to make sure that the change that you're trying to make is like you're changing the thing that you need to change, and you're not gonna accidentally change something else.
Maybe like the first time your regex fails you, like if you've gotten so far with a regular expression and now it just missed a case, and you're like, instead of sitting here and like iterating on that regex and just like keep on tweaking it for these different cases, stop right there. Now maybe it's time for an AST, because you probably saved time that direction.
Exactly, and I think the ramp up here, which is maybe your deeper question, really, I'm advocating for developers to have this in their tool chain the same way they have like linting support and running tests, right? So we should have an easy way for folks to write transforms. We should just take the day or two that it takes to set that up, get that into the project with some examples, and make it so that folks have a path for doing those things. And that can be twofold. You can use that as an opportunity to create a bunch of custom linting tools, and while you're doing that, write support for using. Adding infrastructure for how to write transforms if you need to, but ultimately, like if this is in our projects, it's folks become, even if they don't use it to check in code, even if they use it to just while they're developing something to find what they need, like it's a way to I think level up level up the playing field for like everybody, because the stakes are getting higher. Like we have bigger code bases. Front ends are like huge, right? Really, we're thick, not only thick clients, we have thick servers.
Yeah.
And so, I also think the culture of like, let's throw everything away and start over is like a really expensive one that isn't like a good thing we should be promoting. Folks should feel comfortable with refactoring code, and they should like feel proud about it, because you're able to still drive value for your product and your business while pushing your code forward. I'm personally sick of seeing like front end teams like start over from scratch every like 12 to 14 months. So let's like just not do that.
This episode is brought to you by TeamCity. TeamCity is a continuous integration and delivery server developed by JetBrains that helps you build, test, and release your software faster. It supports all popular build tools, test frameworks, version control systems, issue trackers, and cloud platforms out of the box with no plugins required. TeamCity visualizes your build, test, deploy pipelines, collects statistics on each step, pinpoints the root cause of failures, and suggests which commits might have caused the build failure. The professional version of TeamCity is free even for commercial use, and lets you set up to 100 builds and run up to 3 builds in parallel. For large organizations out there, JetBrains offers TeamCity Enterprise, and right now they're extending a special offer to our listeners. Get additional build agents and new licenses of certain enterprise versions with a 50% discount. Head to teamcity.com/changelog to learn more. Again, teamcity.com/changelog.
So ML, you're obviously passionate about this particular subject. It is somewhat dry. You have to convince people to pay attention to somewhat arcane knowledge like abstract syntax trees, but there's huge value that can come out of doing these refactorings and really allowing yourself to refactor better, faster, stronger. Is this a tough sell in engineering teams, or do you find it's pretty easy to convince people to institutionalize this kind of a tool in their toolbox?
Yeah, that's a great question. I have to say that I think there's a few different things happening in our industry right now. One is like there's like a dopamine hit with that we get from like new tools and new
fresh
things
starts.
And fresh starts. And, there's a problem with like consistently working on new things, which is there's a set of challenges in for developing software that you just don't even get to really explore if you're constantly starting over, like your to do like Hello World app or your create React app or whatever the hell else. Like, great to do that every once in a while. Like, I'm not sure it's like healthy to be creating new projects all the time, in the sense that like there's some real like good engineering challenge that you get from having to understand how to drive value, how to make change while still shipping to production, right? There's like there's a, how do you refactor safely? Like, how do I refactor like a billion hit a month like code base, right? While still pushing to production, and understanding how to do that safely, responsibly. Like, what are the nuances of that? Like, in terms of testing, in terms of like, there's so many interesting things. Like, there's like a class of problems that you just never get exposed to. So for me, the heroes in our industry are really the folks who are working on legacy applications and still driving them forward and continuing to chip at them. And one of my some of my philosophical ideology comes from Martin Fowler, who has a really great article, which I think we're going to link in the show notes. I just sent that to y'all. It's Strangler Fig application. So it's basically he was on vacation somewhere, I think in New Zealand. But there's this tree where, like, it's growing roots and it's slowly kind of strangling the thing. It's growing new roots, but it's slowly strangling the old ones. And so the idea here is the pattern is that, like, you can kind of refactor your application module by module, bit by bit, and while still driving value forward. And I'm personally, like, I'm sick of seeing like the next gen team versus the like old gen team. I've so many companies, you have a group of people that are working on something that is not shipping to production for like 6 months, 12 months, 14 months, 17 months. You get the drift, right? So ultimately, like, you're building a whole set of things where you're not even getting that daily, you're not getting that feedback loop from your customers on like what's working and what's not. Like, you're developing the new version of your thing in a complete silo. And so I think a really interesting problem that I had to solve a few years ago actually was I was new on a team, and I was hired to like re-architect all of the UI, get us off of the legacy code. And it's really funny. I've never actually talked about this story. So I'm realizing now, like, that, like, maybe this is the origin story for me. But it was a backbone application and they wanted to switch to React. And I was like, we're not going to get rid of React. We're not going to get rid of all of these backbone views. Like, the best part about React is it's just a library. And so maybe we just build infrastructure so that this whole new view, this new set of functionality that we're adding, maybe that's React. And, and we were able to kind of push forward having all of our new views be React components, while still leveraging the backbone components. Like, those two things lived next, in one ecosystem. It was a little more work, but we were able to slowly replace everything while still driving value, while getting, feedback from customers in the wild. And like, that's the type of challenge, like, for me, that's what makes like a senior engineer. That's what makes an architect. That's what makes, that's what makes for somebody who really understands like the challenges and nuances of our craft. And so, this is like, we have more code now like than ever. Our forget our code, like, most of our code is actually third-party dependencies. I think Google just did a study on that, and it's like, out of every 10 lines of JavaScript, like, it's one line of code that belongs to the application. So that's a shocking number,
for sure.
right? But if you think about it, I mean, it's no surprise, because the open source model is working. That was what it was designed to do. We don't want to be reinventing the wheel. We want to be building on standing on the shoulders of giants. But at the same time, we need to understand, we need to be able to move quickly and shift, And so if I want to switch dependencies, like, I want to be able to do so in a way that isn't going to set me back, or I want to be able to do so in a way that's safe, and it's not just changing dependencies, it's about upgrading and all kinds of things. And so there's a culture now with some of the larger frameworks, Angular being one of them, where they'll give you a set of transforms with the version bump. So they're like, all right, like new major release, sorry for the breaking changes, but we're now going to give you a command to run so that you can migrate from like 5 to 6, 6 to 7.
That's awesome.
And so the bar is getting, yeah. So this is great. This is like when browsers compete for security and speed and all these other things. So these big libraries are now competing on user experience and DX more so, actually, developer experience, right? And so so the bar is getting higher because the stakes are getting higher, and we can start adopting those practices like in our own code bases as application developers, and that's my pitch.
I like that pitch. And I know we have this shared metaphor that I'm not introducing either of you to it, but we have this metaphor of technical debt and this idea that you are taking on debt in order to gain somewhere else. And eventually, the debt collector is going to come unless you manage that over time. And, in finance, we have ways out. We can declare bankruptcy. Of course, if you do it like Michael Scott, it doesn't quite work, where he just walks out and says, bankruptcy. I don't know if you saw that episode, but it's one of my favorites. You can't just say the word out loud, Michael. That's not how. Yeah, he just goes out into the office and he just declares bankruptcy. And who is it? Oscar, the accountant's like, that's not how it works. You can't just declare bankruptcy. Anyways, off topic. But we have a lot of people declaring bankruptcy with their technical debts. Where I'm trying to get to, because maybe it's part of the tie-in with the Silicon Valley mindset, the startup mindset of like, you have to have a bunch of people spin up new things and then they die, and then here comes a unicorn out of that, right? Like 1,000 failures, here comes one success. Maybe that mindset is tied in with the technological advances, and we get to this point where it's like, well, a new thing has to begin. I'm with you very much so on maintaining legacy code and that being really the software that provides value over a series of years is de facto legacy, right? It's the reason why it's still around is because it's providing real value to real people. But is there a point where you've come across any code where it's like, you know what, you guys didn't manage the technical debt here. There's no. I like the idea of pushing the thing forward, but sometimes you're like pushing up against a wall. Are there limits to this? Yeah, are there limits to this ideology, or can we refactor, all things?
Yeah, I'm sure there's. I'm sure there is. There are cases like although I think they're very very rare, where you have to completely, just abandon ship for the entire project. But with the kind of module by module approach, the idea here is that you're taking kind of one vertical segment and replacing it, and then throwing away the code that you don't want. Right. Instead of or you're doing it, or you're refactoring in place. So either one. But I think for me, an acknowledgement that we don't make enough in our industry, and I think you're totally right about your kind of analysis on, maybe it's Silicon Valley culture, or maybe there's some kind of culture bleeding here with just a race to the top, right? But we don't acknowledge, I feel like enterprise code is it's its own beast in our community, So you're either it's enterprise versus small medium versus the Create React app world, right? And so these three kind of paradigms where I think where nobody wants to be enterprise, I think we even coined the term enterprise dude in a team that I was on. Enterprise dude always ruins everything for everybody, It's so enterprise dude is always relying on the least supported version of something, yes. And is holding back people from being able to upgrade things, Anyways, but enterprise, so real software, software that's been out in the wild, that has had multiple developers work on it, and applications at scale have cruft. Yes. I've yet to kind of see applications at scale that don't use multiple languages, that don't have like just arcane like stories behind why this weirdo thing exists. It's like, all right, when you open this file, you're going to have to turn around 3 times and tap your nose once. Like it's just the most hilarious stories, But applications are living, breathing. They have craft. That's normal. Like, so I want to normalize weirdness because that's just like how applications evolve over time with multiple people. Yeah. And so, it's okay. There has to be some uncomfortableness in our code bases because ultimately, like, you have to have something to be pushing forward as a team. Like, I envy the folks who are like really happy about everything, and congratulations to them. Maybe this talk isn't for them, but this talk is for the like 99% of us that are remaining, that have like hashtag real problems,
I think it's Mike Tyson said everybody has a plan until they get punched in the face. And that's when everybody's plan goes out the window, basically. He knows that pretty well because he's punched a lot of people in the face. I think, code is kind of like that. Like, we all have just beautiful, perfect, pristine code until it hits production. It hits the real world.
Right.
And once that happens, like, stuff, it hits the fan and you got to make changes. And so the longer it's been in the real world, the more craggly it's going to look. I'm looking at this picture on Martin Fowler's blog of the Strangler Fig application. I'm thinking that code that tree... That's an abstract, some kind of a tree. That tree is crazy looking,
It's crazy looking. But yeah, I mean, at the very minimum, you always have the CEO button, right? If your code is perfect, I challenge you to, to find like, one decision that wasn't like the CEO button decision where it's just like, just put it there, make it happen, like ship it now, like,
Thanks,
so,
CEOs.
Yeah.
Well, now your talk is the first day of the conference, right? So you're on day 1. That's the October 14th. The conference actually happens October 13th or 15th. There's some workshops, et cetera, going on. If you are planning to go to this conference, which I would suggest you do so because, hey, we're going to be there. As a matter of fact, we're planning to have a live JS party at All Things Open. ML might be a future panelist or a future guest panelist on JS Party, so hopeful there at least. CML day 1, but I'm not sure which day our live thing is, but it's definitely going to be there. All Things Open happening in Raleigh, North Carolina, October 13th through 15th this year. And if you are thinking of registering, I would say that right now between the end of the month, their mid-tier pricing is still active. So October 1st, it goes a little higher. It's still a very inexpensive conference. Even on its most expensive ticket period is $279. So not a very expensive conference to go to. Amazing speakers. ML, you'll be there, of course. Jared and K-Ball will be on stage doing something. I'm not sure. What is the plan, Jared? Do you have a plan?
The plan will be revealed when the plan is revealed.
Yeah, it's going to be it's a fantastic conference. It's just incredible speakers and lots of I think it attracts an audience that is kind of really diverse and also has just an interesting breadth of problems. And so highly recommend it. I'm really excited to be speaking there this year.
I want to give a quick shout out too to Todd Lewis, the organizer of that conference. He does such hard work to make that conference happen each year. Every time I talk to him, he's always moving. He's never still. He's always going. So Todd, great work on this conference. Looking forward to being there. Our first time there was in 2016, so we're glad to be back. And Emma, thank you so much for your time today and sharing your wisdom. You are welcome back. Thank you so much. And it was fun talking to you today.
Thank you so much for having me. It's been a pleasure.
All right. Thank you for tuning into this episode of the Changelog. Hey, guess what? We have discussions on every single episode now. So head to changelog.com to discuss this episode. And if you want to help us grow this show, reach more listeners, and influence more developers, do us a favor and give us a rating or review in iTunes or Apple Podcasts. If you use Overcast, give us a star. If you tweet a link. If you make lists of your favorite podcasts, include us in it. Also, thanks to Fastly, our bandwidth partner, Rollbar, our monitoring service, and Linode, our cloud server of choice. This episode is hosted by myself, Adam Stacoviak, and Jared Santo, and our music is done by Breakmaster Cylinder. If you want to hear more episodes like this, subscribe to our master feed at changelog.com/master, or go into your podcast app and search for Changelog Master. You'll find it. Thank you for tuning in this week. We'll see you again soon.